Okay. 10 minutes early, huh, Jezebel? Is that because you can't wait for it to be over, because your side is going to end? But anyway, yeah, almost there. Let's see. Okay. Oh, this class starts in 1 minute. I actually, I don't have that much for today. Actually, I was thinking about it. I do have. It's good that you came. I remember I told you you should show up. I will definitely discuss with you guys the questions that could be in the exam. I'll give almost as much guidance as before, but not quite as much, because from this. Okay, this 1:30 is not quite there. Let me 1 minute. Let me wait 1 minute before I start talking about things. Oh, there it is. Right. So, so I was thinking what to do today. It's good that you came, and yeah, you'll get something out of coming. As I mentioned, I should go over, give you guidance. But aside from that, I decided not to put the questions on the. So I just put up two pamphlets, two PDFs. With all the answers in there for possible problems. But the truth is that I'm going to tell you the problems, and it could be that I add one of the problems from this, or maybe even a couple of problems similar to this. So I'll just go, the answers are in here already. So what I think we should do is, let me, 1 second, sorry. Let's see if, okay, the pencil is charged. What I think we should do is go over whatever you think we should go over as far as this goes. Then, of course, I can take some time to tell you about the final. I pretty much made up my mind about what the final is going to look like, but you know, I will do a few changes. Let me actually, no, sorry. We should go the other way in case people trickle in. I shouldn't tell you about the final just yet until at least, I don't know, 15 minutes into the class, something like that, because people do trickle in, and I don't want to. Those students to miss the material on the final. So we should start with these two PDFs. Again, I don't have that much for today. We're almost done, as Jezebel notes, almost there. You have to realize, though, that the final, I'm going to have to make the final just a little bit harder than the second midterm. Or because the second midterm, yeah, the grades were pretty high. You can tell that already, right? Because I don't know. Just out of curiosity, I don't have it right in front of me, but you guys do. Can anybody tell me from Canvas, the Canvas exam, what was the mean score? You can read it on Canvas yourselves, can you not? What is the mean score for the class for the second midterm? 19.9? Right. Remind me again, how many points was that? How many was the point total out of 23? 19.9. So that's pretty high. That's excellent. Let's just say that's a combination that maybe I made the exam just a little bit too easy, and also you guys did very well. So we'll go with both. But that's pretty high mean for that exam. So look, I have discussed it. Let me say this again. I think I mentioned this already, but let me say it again. That I did discuss the situation with online classes with the chair of the department, Monica Kress. And just to get a sense, I don't see the professors that much, the other professors these days, so I don't know what everybody's doing. No, Ryan, I'm not punishing anything. Brian, why don't you see, that's not really, that's not punishing you for what? What am I punishing you? If anything, I gave you I gave you the questions in advance, Brian. So I'm not sure what punishing you mean. So again, as I was saying, oh, okay, you were just kidding. Okay, fine, you were kidding. I do, but the thing is, when you say that, things like that is gonna. Let me discuss the grades again situation, because I don't want somebody else to panic over grades or something like that. So you were kidding, that's fine, but somebody else in the class might not take you as kidding. Let me please, before anybody panics about anything, let me say what the situation is. Of course, you would like, at some point, you would like the good exams to be curved. sorry, but when the class does bad, curve that. But when the class does very good, then don't curve that. So it would be one exam curved, the other one not curved. Well, you know, that's kind of a funny thing. I can't just curve when the class doesn't do as well. Now, before, you know, in case somebody is thinking like, I thought Ryan was thinking, but he was just kidding. What I was discussing is that I did talk to Monica Kress, the chairman of the department, about the possibility of doing a little bit more grade inflation on online classes than we do in normal situations. So I'm perfectly happy to do that. And then I found out that, yeah, probably other professors might be doing that as well a little bit. So from her, and again, I didn't really conduct some kind of a census to figure out who's doing what. So I don't know exactly what there are other professors in Physics 51. But anyway, Monica Kress is the chair, so if she says it's okay to do a little bit more grade inflation, I'm assuming that the other professors also know that. So that's what I'm going to do. Okay, but I still have to curve a little bit, otherwise, So again, if I'm going to curve either I don't curve at all, but then I wouldn't curve the first exam, or I curve both exams. I'm not going to curve one and not curve the other. That doesn't seem like a fair, reasonable thing. What I can do, if I do curve, what I can curve is to a higher grade. That would lift everybody up. Okay, that's okay, and that's reasonable, and I can do that. But I cannot just keep one exam where everybody did very well and curve the other one. So what I could try to do again is maybe normally you would curve maybe to a B minus. So I can try to curve to a B this time, which is pretty high. So that would mean that's pretty good actually. That would mean if you're getting the mean of the class for both exams, then you're like at B range already. And then if you do better in the master in physics, if you're doing well at that, then you would be on top, or you could easily go to a B plus or higher. The master in physics is worth quite a bit. But again, it's a little funny to not curve that one exam where you guys did super excellent, of course, but curve everything else, so I think the more reasonable thing, I'll send more details about exactly how I'm going to handle the grades, but I think the reasonable thing is to curve everything, like curve to a higher grade, to a higher mean. So to a B, that would be. Normally it's a B minus. It used to be C plus, but everybody's going through a little bit of grade inflation. I have no problem with that. If everybody's doing that, I'm happy to do that as well. But this would be a little bit higher than that still. Okay, so please keep in mind that I will do that, and so don't panic about anything. Don't get all. So you can, but it is true that you can already, based on that. Yes, it's true that to get a B, you have to do pretty well in the second exam, not so much in the first one. To get a B, you didn't have to do that well in the first one, but the class did very well. You got 19. That's 20 out of 23. That's pretty high, you know. So anyway, I could consider not curving for anything and see if those grades are reasonable. And so I'll check into that. I'll send more details, but right now the normal thing would be to curve everything and then curve to a higher grade, a B. So that's probably what I'm going to do. So I don't consider that punishing because one time you didn't do very well. So for the first exam, that's going to help the class, not hurt the class. The first exam. Okay. Oh yeah. So since you have it in front of me, so you're kind of telling me the things. You know, I don't use Canvas for grades. You should be aware of that because Canvas will include in the mean, maybe students who didn't even take the exam, things like that. I do my own grades with my own grade sheet and so on. But in any case, it's not going to be that different. So what is the mean that it says in the first exam in Canvas? For the first exam, 20.8 out of 29, right? There you go. So for that one, the curve would help you, right? Because it's almost like the same grade, but many more points. So yeah, so I have to curve either both or neither. So I can't. So I don't think that would make any difference whether I did it one way. Look, I'll do it whichever way is best overall, but I have to curve both or not curve either exam, I guess, And probably curving helps. Anyway, I think what is going to end up happening, I just curve to a B. Okay, so that's fair. So then what should you tell yourselves is going on? Well, it's not that hard then for you to figure out. I will send after class, I will send the class email. Now the deadline is already passed for the master in physics for everything. So I'll send the class email with the total number of points, and then you know how you did in that. So for everything, in fact, let me commit to that. Let me just say that I think that there's no problem with that in my mind. So let's just commit to that. I'll curve everything, but I'll curve everything to a B, which is a little higher than normal. So basically, if you check everything and you're keeping pace with the class, then that's a B, which is very reasonable. You know, you're doing like the mean of the class. If you did better than the mean, well, then you could end up with B plus, A minus, or even A or A. I'm sure there will be A's, of course. Okay, so I think that's pretty good. If somebody has a problem that they think they're not gonna, I try at the low end not to give anybody below a C minus for sure. You would really have to have done very poorly to even get a C minus. But once in a while, I do give C minus. I know that a C minus for engineers sometimes means that you have to retake the class. I try very, very hard not to give D pluses, but avoiding C minuses is a little hard sometimes if somebody didn't do very well on anything, say for instance. So on the bottom end, I do try to lift people up to the C minus range. At least the lowest grade I try to give is a C minus. Okay, but that could pose some problem for some of you if you have some engineering requirements and so on. If you have a situation like that and you want to discuss that, I don't know if there's anybody like that. To be honest, I haven't gone through all the grades to figure out what the situation is. But actually, you can tell yourselves pretty well already. So if you want to discuss your particular situation with me one-on-one, don't want to discuss it with the class, I can put you in breakout rooms. Today, after we're done with the other material, I can put you in a breakout room and we can discuss it individually. If there is quite a few of you that want to do that, then you have to wait until I get to you. It takes a little bit of time to go one by one, putting people in breakout rooms. But I can do that, of course, no problem. So if what I just said is not enough for you to figure out what you want or what your situation is, then let's do it. Let's do one-on-one. What else to say? Okay, aside from that, now that time has passed and it seems that more people have filtered in, let me start with the problems that will be in the exam. Okay, so let me start with that. Okay. And then if there is something here that you want to go over, we can do that. But I decided, again, all the answers are already in here. And I gave you 2 PDFs of this. So maybe we can go over selected problems, just to remind ourselves. My suggestion is that we make sure we cover at least the ones that I'm going to tell you for sure are in the exam with this PDF. So let me first give you the ones for sure in the exam. So for sure, let me, 1 second. Okay. So for sure in the exam are these problems. LRC circuit. We did ones just like it, just like the one. So again, there is no trick, nothing. So what things are you going to be asked to figure out? So this is a series circuit. So of course you're going to have to know Imax, which is the amplitude of the current, and it goes like a sine, but you figure out Imax, just like what we were doing before. Then you're going to have to figure out Vmax R, and then also, the Vmax, or the Vmax are everywhere in each of the. Then you're going to have to figure out the power. Remember, I gave you the formula for that. Then you're going to have to figure out the resonant condition. Actually, this is a different problem, but there is also another problem that is an RLC circuit, and you have to figure out the resonance condition, evaluate that. So nothing specific, nothing difficult. You can, just straightforward. RLC is the circuit we just covered here at the end. There's definitely a problem like that in the exam. What other problems? There is a problem similar but not identical, similar to the one we were just doing the last class. This is where you have to use Faraday's law. And then remember what we're doing. So when you use Faraday's law, you have this is that formula where you do minus, and this is the flux of the B field. And then you got to figure out what's changing. And there were three things that could change when you say ddt. You could change the B field, you could change the area of the loop, or you could change the angle between the B field and the loop. So you just by rotating the loop in a B field, that turns into an electric motor. We didn't really emphasize that one. So let me already, in case that one is bothering you, don't worry about it too much, because that's not the one I picked because we didn't emphasize it. But it's kind of like the same thing. It's a little harder to visualize. It makes for more difficult drawings in the exam. That's why I didn't pick it, because then you have to start changing the geometry in order to, you have a B field and you got to change the geometry of the loop. So start doing this with the loop so that the flux through the loop changes. But that's always a harder drawing to put into an exam. So I did consider putting that, and I argued myself out of it because I couldn't find a good way to do the drawing, actually, where people wouldn't get, would lose points just because of the 3D drawing. So I decided not to do that. So it's one of the other two. But what you're supposed to do is figure out the voltage and also the direction of the current. You have to figure out the direction of the current to get full credit. So whether it's clockwise or counterclockwise. Okay, that's again not very difficult. I took that from the book. Okay. None of them are very difficult, but I may add something from the PDFs to the exam, actually. I have to think about that. There will be a third problem. There are problems, practice problems like that, by the way, there's a practice problem definitely like this. This we just did, so that's taken care of. Then there is the one about electric fields. At a point in space. So electric fields at a point in space. So in that case, it's like what the stuff that we started with. You have remember that stuff. This one was a little harder. So I would definitely. There are practice problems for this as well. So go ahead and do it. There are definitely practice. I think there might be two of them. Two practice problems in the PDFs I just posted. That are just like that. Find the electric field here, and the solutions are in there. So again, please, what I would suggest is do it without looking at the solutions. Don't fool yourselves. Do it. Do a problem like do a practice problem, but don't look at the solution. Do it yourself, then look at the solution. Otherwise, many times it happens that people look at solutions and they think they know how to do it, and then they find out they didn't later at the time of the exam. That's not what you want. But anyway, it will be a problem just like that. You could put charges anywhere. Now you're asking the electric field at a point in space. Now it's not this one, but so the electric field, right? Well, it's just that. So this is a vector problem for sure. So you have to do X components, Y components. Again, there are practice problems in the PDF. So please do it. Otherwise, yeah, I can foresee people losing points there for sure. This one, I don't see how you're going. We're already, I suspect that this is going to be one of those almost everybody gets it. This one probably as well. This one, you have to go through the procedure. You can't jump steps, otherwise you're not getting answers. So I suspect that more people will miss this one. That's my suspicion. Okay. There will be a problem Yeah, there will be a problem of this kind. Maybe this is the one we should practice. I don't know. Okay, yeah. It was similar. There was something like this in the exam, and quite a few people did get it wrong. Remember, there was a problem. It wasn't meant to be very hard, but there was like 2 protons. And then we had so it's like this problem. I'm not saying it's exactly the same problem. I'm saying it's very close to this problem. In the problem in the exam that we already had, we had 2 protons, and they were close to each other at some distance. And then so these were 2, I think that was the problem. But anyway, just like this. And they were very close together. And then you release them, and the question was, what is the speed at infinity? And this is where you use that formula where you say it's the kinetic energy initial, which is 0, plus kq squared, because they're both protons, over r. That's the potential when they're close together. And r is the initial distance. You can say r0, I guess. And then you release them, it goes to infinity. And then the only trick here was that since you're releasing both protons, then both protons have energy. So if you ask what is the speed of any one proton, well, it's mv squared plus 1/2 mv squared. And the thing that made this easy is that you didn't have to deal with momentum conservation at all. Now, there was this subject of collisions of protons and electrons that actually got complicated on master in physics. Because in that case, there are situations in which you don't have enough information just with energy conservation. You must use conservation of momentum. And sometimes people like to use angular momentum. There was a problem like that in master in physics. It was pretty tough. Where you're shooting, there was like some gold atom, and you were shooting some particle at the gold and trying to figure out how much it deflected and stuff like that. It's not going to be one of those complicated ones. It will be one where all you have to do is you write energy conservation properly, and that's it. Okay, so the one that for this case that we had, what people missed is that you had to put the energy for each proton, because they're both moving when they're moving away from each other. So it's not, you can do the problem a different way where you fixed one proton and you let the other one. So in that case, only one of the protons is flying away. But this was a situation where you put them close to each other and then you let them go. So at the end, when they're separated by a very, very large distance, then there are 2 kinetic energy terms, one for each proton. So that was the only little wrinkle there. Other than that, so there's something very similar to that in the exam. Okay. Then, yeah, I can tell you 2 more. Again, I'm giving you the idea, the ones I may exchange if I find that this is too much like stuff we've already done. I may exchange one of these, not more than that, but one of these problems with something from the PDFs, as long as it's fair. So if you look at the PDFs for a little while, it will help you. Okay, so it will help you to prepare with what's here already, but I may also include a problem from the PDFs in here in this exam, from this practice problem PDFs that I just uploaded. But what I have so far that I wanted to put in is wire problems again. So magnetic field. Of a wire. Now, in the last exam, what we discussed was the force between the wires. So I could do that, or I could go back to asking what is the force on a charge. So it's a little bit more, we've done this kind of thing, either one. Okay, so prepare both. So you can have 2 wires. We did this in the exam already. And you can have the force between the wires. That was F over L, that we calculated that in the last exam. But we can also go back to asking what is the B field at some location. Not the force between the wires, but the B field at some position, and then say put a moving charge over here, and then calculate the force on the charge. So some variation of the wire problem again. Okay, so I'm not going to pick exactly the same one, but it's along the lines of what we already did in the last exam. but I'll change it up a little bit to make sure you remember what the situation was with that. So instead of asking the force between the wires, I could ask, now I shoot a proton near the wire. What is the force on the proton? Say. So that's another problem I was going to put in. And what else? I have one more. Let's see. Energy conservation, the version of the electron gun problem, maybe a little bit easier than that one, than the one we did in the first exam, but another version of that, a simple version of that. In fact, that's what I'm going to put in. A simpler than the first exam. So let's say simpler version of the electron gun. The electron gun was you have two plates. Remember, it makes a little bit of a difference if it's two plates or one plate. So I can change the minor things, but I'll have a plate or two plates and I'll shoot an electron or a proton in there. And then I'll ask a few questions about it. Maybe how high it goes before coming back instead of shooting it at an angle, something like that. Okay, so this is from the first exam. So those are pretty much it, the ones I have. So plus, let me just be specific. So plus, so if you have any questions, let me know, but I'm being pretty specific already. Plus one problem from the PDFs. Now it could be, it could be the Kirchhoff's rules. Maybe I should put one of those in. Maybe it could be capacitors and resistors in series or parallel. So a circuit problem, probably. I haven't done this part yet, so I don't know. But maybe it's circuit. That would be nice because here I don't have any circuits.
Is this from the PDF that you just added?
Yeah, I just added PDF 1 and PDF 2. Now, I'm just saying that as practice. I'm not saying I'm going to get that problem and stick it in there. But there's we'll go to the PDFs right now. So if I include a circuit problem, the question is, are there circuit problems in that in there? So the answer is yes, of course. Now those have quite a few. Yeah. Well, these are, I guess you could call them this short answer. This is like a short problem. Yeah. No, there will be multiple choice. Absolutely. Let me see. Problem 9 on the first one. Oh, yeah. That's true. It is missing. All the other ones are done, but this one is missing. I see that somebody, I got this from, I had it from before, from doing the labs. By the way, they already sent me grades for the labs. I hope that nobody missed those points. If you're concerned how you did in the lab or something like that, have they shared the grades for the labs with you guys already or no? Or do you know already? You don't know.
Like our lab, he hasn't even graded like half of our lab reports. I'm not really sure how he would send the grades to you.
Well, actually, I did receive an email from the overall, not from each individual lab instructor, but I received an email from Ranko Heindel, who is the one who actually oversees the lab overall. And he seemed to indicate that but maybe he was just talking about his own grades. Okay, anyway, so maybe you're right that I don't actually have your grades yet. So what I'll do is when I receive the grades, I'll let you know that I got them. I will include the grades. In the syllabus, it says that 10% of the grade, 10% of the grade is labs. But you should keep in mind the following. Okay, fair enough. So it was just Ranko sending his own grades to the group, I guess, not everybody. But again, 10% of the grade. So what does happen is, as long as you grade, it won't make a difference whether somebody got 95 and you got 98 or vice versa. That's not going to make that much difference because it's only 10% of the grade. I don't remember if I said 20%. Whatever the syllabus says, that's what I'm going to do. But I don't remember if I said 10 or 15. So whatever it says in the syllabus, that's what it is. But anyway, whatever it is not that much. So long as you are pretty close to the mean of the class, well, it's not going to make any difference. But what happens is that once in a while, somebody will really underperform. It's hard to overperform, but even though sometimes some instructors do give extra credits, or they used to. I don't know if they've changed their grading policies or what. But so some students ended up with more than 100%. So some people could end up with 100. Few students could end up with 120. I've seen that happen. 120% because of extra credits and things. But anyway, usually what ends up happening is that it does not matter if you get 95 or 98 or 99. That doesn't make any difference, only 10%. But if you get 60% and the class average is 93, then yeah, of course that's going to make a difference for you, because 10%, but it's such a big jump between the class and you that it would make a difference, a little bit of a difference. It's not going to flunk you, but it will lower your grade, yeah. So long as you've been completing the labs and you get a sense that you're doing roughly like the mean of the class, then you really don't have anything to worry about. It's only if you feel that your lab grade is a lot worse than other students' lab grade. I'm not sure how you would know that or not know that. So if you're a little worried about that, then when I receive that, you can ask me and I'll let you know how you did on that. Okay. But right now I don't have it, obviously, since the professor hasn't even given it out, that sounds like. I'm assuming that the professor will give the mean of their lab grade. And if you are close to that, then that's it. Okay, so long as you're not way off, then it's not that much weight. Okay, what else? Yeah, you're saying this is not completed. That's true. You want to try to do it right now? Let's try to do this right now. Of course, it's not going to be very hard. So, and it is kind of similar to a problem I said might be in the exam. So maybe it's worth doing. So I'm pretty much done with what I have to say. I'm glad how many of us are here. Pretty many, right? So I'm happy that you showed up. That's going to help you. Obviously, I gave you a bunch of questions in the exam, so that will help. From here on out, I don't have any preference. What we should try to do as a group is do this one, fill it out, and then see if we agree on the answer. And the other answers are already in there. So maybe that's a good thing to do. Is that what you want to do? Sound good? Jason, did you give it a try? That problem? Did it cause you trouble? Okay, so you don't know if it gives you trouble or not. Well, in general, the ones that require vectors are the ones that are harder. Now, in this problem here, the problem is that it seems to not give you enough information. And the reason why it doesn't give you enough information is because you're actually relying on a square grid. Let's look at this problem since you're interested in that one. What they're trying to tell you is, well, you have the formula, right? Let's remember the formula for the magnetic B field. So they're saying, what is the magnetic field that points PQ due to the arrangement? Okay, so you have a bunch of wires that carry 1 amp. So let's just, I'm not going to get the answers. You can calculate the answer. I'll write down the equations. We'll see how to do it. But remember, what they're trying to tell you is that the square grid, it has a dimension of 1 centimeter. So you have to start counting square grids in here, and it's a little bit. So let me try to do it just based on what I can see here. But this is what they're trying to say. Okay, so we have the B field due to a wire, right? So the B field due to a wire is mu0 I over 2 pi r. Okay. So now we want to figure out, but you also have to, it's not just, this is just the magnitude. You also have to figure out what is the direction, because the B field is definitely a vector. So you have to say, okay, what is the direction of the contribution of each? So this is not a bad one to practice, actually, because I may give one just like this one. So thank you, Jason, because that's the one I was thinking of giving you, actually, one like that. This one has three wires, yes. I was thinking of 2 wires, but 3 is okay too. Okay, so how will you do this? Well, you notice that two of the wires, the current comes out of the page, and one of the wires, the current goes into the page. So let's not do both points. Let's just do one of the two, and then you can try your luck with the other one. So let's say, for instance, you want to find out. So again, it's a little hard to see what the geometry is. So I'm assuming the distance from I think based on the drawing that the distance from there to here is the same as the distance from there to there. And certainly the same. So what I'm trying to say, this wire, the distance from that wire to that point, so let's calculate this point. Based on my observation, seems to be, but it's a little faded, sorry about that. I think it's the same distance, but it doesn't quite look exactly the same. But anyway, so assuming that's the case, that's the same number, and so there is 2 centimeters, so this is 2 centimeters there, right? And there are how many centimeters? Is 1, 2, and 3, I guess. Is that 3 and 3 or 2? 1, 2, 3. Oh, it's like 3 and 3, I think, or not. Well, let's just make it, I can't tell. Maybe let's make it 2 and 2. So let's suppose that that's where I cannot see exactly what's going on. Let me look at my original, actually. Well, doesn't help either. Okay, 1 second. Well, it won't make any difference, but let's just say 2 and 2. What the hell, doesn't matter. So 2 centimeters, and there's 2 centimeters there, and there's 2 centimeters there. Okay, so then you can find out this distance, right? And then you can what you can have to do is in what direction is the B field? Okay, so remember how this works. That's the only difficult part here. So for instance, let's do the B field due to this wire. So this is 2 centimeters as well. So that part is easy. That's the R that goes in here. So it would be 2 centimeters. Now you're gonna calculate this R, and that R is the same, but you have this R. Now you have to ask in what direction is the B field. So remember how that works. B field is a vector. So you put your thumb in the direction of the current. So in this case, it would be into the screen, computer screen, right? My thumb goes into the computer screen, and then my fingers wrap around into the direction of the B field. So I'm doing the bottom wire now. So is the B field that way? So that my fingers come this way. So the B field is, for this wire here, the B field is in that direction. Okay, like that. No, it's into the computer screen. Oh, okay. Agreed, Karen? It's an X. Remember, X means like the arrow, like going into the computer screen. So like that, your thumb goes into the computer screen, your fingers curl this way. So whatever, whether it's clockwise, right? But whatever, what I drew, the arrow I drew, right? Okay, so that's the contribution due to this wire. But then you have to say, okay, B equals mu0 times I. What is I? Well, it's 1. And then it's 2 pi r. What is 2 pi and what is r? Well, it's 2 centimeters. So 2 times 10 to the negative 2 meters. Okay, so that's the contribution due to this wire. Agreed? And now you have to be a little careful. So say, let's call that the X direction. So this would be BX, and there is no BY. And it would be positive because, again, what I suggested to you from the very beginning is that you look at the diagram and you just decide ahead of time whether it is BX positive, BX negative, BY positive, BY negative. So in this case, the bottom wire, that's the one I'm doing, would have BX positive, and it would have BY 0. At that location. You put your thumb in the direction of the current, and then your fingers curl to the right. Agree with that so far? We're going to do something similar to this in the exam. So yeah, please think about this one. That will help. Okay, now what do you do next? Well, you got to figure out the direction and the direction of the other two. Well, it would be perpendicular. The direction of this B field is going to be perpendicular to this, so it's going to be in that direction. Actually, it's coming. Sorry, let me see 1 second. Oh yeah, that's correct. So this one here is that wire. Okay. Okay, I tell you what, since it's going to be in the exam and I'm making a little bit of a mess of it with my drawing here, let me calculate everything. So in that case, let's just go a little bit further, but you can see how this is headed. But I'll give you the answers to make sure we all agree how to do this. I'll send you the answers. I'll do it on a piece of paper, take a picture, and upload it as well. But basically what happens here is the R changes because it's 2 squared plus 2 squared, 4, 8, and then square root of, right? And then, so that's the distance R. And then the current would be what? 2 amps. So this one, this arrow would be a little longer. Is that 2? Sorry, what does it say? Yes, 2. Okay, so this B field would be in a different direction. And now you have to do the X component and the Y component. You add the X's and the Y's separately. And then finally you get the net. Okay? So yeah, let me write it nicely on a piece of paper to make sure we all agree, since you will find something similar to this in the exam. And I will upload it. I'll take a picture and upload it onto Canvas. Okay. Any questions? Any other questions? Things from before? The other one that is kind of good to practice is the one, make sure that you know how to do this. For instance, make sure that you agree with this one with the signs. I may end up putting something like this as well. You see, what I could do is add a few more of these problems and then remove multiple choice questions from the exam, or just keep the number of problems I told you and then add multiple choice questions. So based on what I have right now in the exam, there would be something like, let's see, how many multiple choice questions? It would be like at least 10 multiple choice questions, actually, maybe even more than that. So if I cut off some of those multiple choice questions, then I could add a problem like this, for instance. So I haven't decided exactly what to do. But anyway, pretty much based on what I already told you and based on these practice problems, if you go through them and you're pretty confident with all of those, then you'll be fine. Now, let's find the one that for sure we needed. That's the one with the electric field, where you're calculating the electric field. Let's find that problem in one of the two. So this is another circuit. This is a thought question about the circuit, pretty much. This one actually takes a long time to decompose and to bring back to, you keep doing series and parallel, and you have to have the idea clear of what you mean. So this might be worth practicing as well. Yeah, pretty much all of this might be worth practicing, to be honest with you. If you're comfortable with all the problems here, then pretty much you're ready to take the final for sure. But the one I meant is problems like this. This is the kind of problem right here that people keep getting wrong, because they're not everybody. Some people are very comfortable with it by the end of class, and they're never going to get it wrong again. But others, they keep jumping steps or trying to do their own approach instead of following the everything, whys of everything, add components, find the net. So I would totally suggest for you to practice this one and then look if you get the same answer. Yes, correct, it is. That's why Jason was able to look through it, right? Jason was the one that told me that the answer was not there for one of these problems. So obviously he got it from Canvas. Anyway, so what I was saying is, this problem is kind of like that problem. So these two are kind of repeat. But so yeah, you can look at this one too and make sure you got it. You agree with that. Let's see what else. This is a pretty easy one that will show up. This will show up in multiple choice questions, this type of a problem. Well, this one we did at the beginning of the class. So again, it could show up as multiple choice, this kind of a thing as well. So pretty much all of them, to be honest. Now, I did guarantee you that one like this would definitely show up. And this is one. Yeah, that's right. So there are two. So we're going to go to the other one. I've been focusing on this one. Now we can go to the other one. But yeah, I did say one just like this will definitely be in there. So please make sure you agree with this. Okay. Now I can tell. Look, let's do something else. Last time I tried to say, okay, we haven't been having that much office hours. So I feel a little bit guilty about that, but you know, it's kind of like the online format is not that great for office hours. Last time I tried to do office hours, not that many of you showed up, but people still did very well in the exam, so I didn't feel bad. I may try to arrange office hours, but I don't know. How many people want office hours? Like maybe try to go through this on their own. So now you do? Okay. So since we haven't had office hours that much, let's go ahead and try office hours. My suggestion for office, and again, if I cannot do too much because then people cannot show up and so on, but we could have one more office hours. So that would be my suggestion, and this is purely office hours, so you don't have to show up. I'm going to tell you already what I'm going to do. What I'm going to ask you to do for office hours is to try by then to practice. So let's do it this Wednesday during regular class time. Whoever wants to show up just to go over these practice problems. So maybe you missed something, or maybe one of the exam problems from the first exam as well, if you want. You can look at the first exam. So here's my suggestion. You prepare these two PowerPoint, this is one, and then there's also two, which is kind of similar though. Oh, no, this is the one I was just doing, isn't it? Yeah, it is. Okay. So I was doing that one. Wait a minute, are they the same? No, they're not. Oh, okay, good. They're not. Or they are. They look the same. Oh, maybe I downloaded the same. Oh, are they? Oh, that's what you meant, Jason. Oh, okay. Yeah, that's my mistake. Okay, no problem. Yeah, that's okay. Well, I have one more. I'll upload it right away. Look at that too. So there's one more set of problems. I was already going through it. So that's what you meant, Jason. Let me correct that situation. These are the same. You're right. I can just, okay, so, okay, great. Now there are a few additional ones, but not that much. We went over it is the RLC problem. We did that before. There is a Faraday problem in the other pamphlet. So I'll upload it today. So here's what we do for the next office hours. And this is how it will help. Based on the problems that I told you that are going to be in the exam, based on the exams we already had, and based on these two practice problems that I'm going to post. So I have to post one more. Then go through that a little bit before the next class. So, and then you tell me what you want me to go over. Otherwise, right now, I kind of ran out of material. So, because you have the answers in here, so I don't know exactly what you would like to do, what's confusing. Maybe the best ones would be like the electron gun from the first exam. No. Oh no. Oh, you couldn't. I mean, this week. How could you have? Do you have office? You have a final this week already? On Wednesday? Huh. Oh, I see. Okay, well, sorry about that. Then I cannot do it. If the finals are, because what's going to happen is no matter what time I arrange, there's going to be somebody who's short. I thought the exams started a little bit later, but if you already have one on Wednesday, then forget it. Can't do it. So this is going to be it. So whatever you want me to go over, that will have to do it. I can't have office hours just for some students, and then some other student cannot show up. That's not fair. Okay, so just you let me know now, and that's what we go over. Okay, while you think about it, if you want to think about it, let me see if I can have a very quick. I think I should be able to upload the other one. Actually, no, I should do that after class. It's fine. I have one more too. Yeah, the electron gun program. Let's do that. Let's remember how that went. Now I do have the answers on. There are a bunch of the practice things, but let's do it together one more time. Let me. Okay, I don't remember exactly the problem. I'll just come up with my own problem here. Okay, for the electron gun. It won't be exactly a one in the exam. I don't remember which one was the one in the exam. I think it was just the 2 plates, right? Wasn't that the one? Let me try to remember. I think the one in the exam was like this. So let's do that one again. Remind ourselves of how it went. And yeah, it won't be this one, but it will be one very similar to that. The one in the exam, as I recall, was the one where it went like this, 2 plates, and then you shoot the electron, and it goes this way. And then you have to say, okay, and then it smacks at the bottom, and then you say, okay, you have some initial velocity v0, and the problem was, what is the final velocity when it hits the bottom plate? So that was the part. You can definitely do that part with energy conservation. Okay, then there was a second piece of the problem where I was asking, okay, well, how far will it go? And that part you cannot answer with energy conservation because the distance along the x-axis is not part of the energy conservation formula, right? So that part you're not going to be able to answer. But for the initial part, where you ask, what is the final velocity? You could solve that with the kinematic equations, and some people did. But the fast way to solve that was just to use energy conservation. So let's do that right now. So you have an electron, and what I told you about this, that the way to solve this is always just to think of, don't worry about the signs, just make sure that you start out by knowing what the sign needs to be. And then you don't have to worry about what the sign, trying to find out how to work out the signs properly. So the sign needs to work like this. You shoot an electron. In this situation, it went like this. You shoot an electron, and the electron has some initial velocity. You shoot it horizontally, in this case. And then you ask, what is the final velocity? Well, because the electron is losing potential energy, it's going, so this was an electron. And so this was the positive plate, and this was a negative plate. So there's negative charges over here. And then the first thing you have to do is, what is the electric field? Well, that's going to be sigma, which is the charge per unit area, divided by epsilon naught. There is no factor of 2 in this formula because it's 2 plates. When it's 1 plate, there's a factor of 2, but when it's 2 plates, there is no factor of 2. So quite a few, as I recall, quite a few students missed that part. But this electric field here, inside, is equal to that, and there is no factor of 2. Okay, what else? Okay, so that's the electric field. Now what you have to say is, okay, great. So how should I write the potential? So you have 1/2 mv0 squared. That's the initial kinetic energy. Now you have to figure out what is the initial potential energy. Well, we're gonna call the initial potential energy a value, and what you have to do is lose the potential energy. Okay, so you have initial potential energy, but then at the end you lose the potential. So you have to make sure that the final velocity, this is the point, the final velocity has to be greater than the initial velocity. So you work out the signs based on knowing that. Okay, because I like to put an absolute value sign. So let's do it that way. So I know the final has to be greater, and I'm going to define the final potential energy to be 0. So it's easiest to start with the final and say 1/2 mv squared plus 0, no potential energy at the end. Okay? That's how I'm going to start. Now, if I say it has no potential energy at the end, and I know that the final is greater, so it goes faster and faster towards the positive plate. So I know the final speed is more than the initial speed. Then, therefore, I have constrained to put a positive charge on the other side. Otherwise, it wouldn't give more. So then I have 1/2 mv0 squared. And of course, the next term, which is the potential energy, that must be positive. Otherwise, it won't give me a greater final speed. Okay, that's kind of like the same thing as it doesn't matter as an electron. It's the same thing. If I throw a ball, initially the speed will only be horizontal, only be along the x-axis. That speed doesn't change, but the vertical speed keeps increasing. The vertical velocity keeps increasing. And then it hits the floor. Well, of course, when it hits the floor, it's going to go faster because now it has the x component, but at the bottom, it also has the y component, which it didn't have at the top. So, of course, I need something positive here. Okay, so what is the positive? Well, and then actually, you don't even need to look at the book or anything else. You can work out just by units, you can work out the right formula for this. So let's think about this. When you do gravity, you just have mgh. Right? So now here, what is the corresponding thing here to mg? Mg is mass times gravity. So here the corresponding thing would be QE. Since mg is a force, and then I put h. Is that the right thing? Yeah, of course it's the right thing. So you just put QE. And then again, you have to have positive. So ignore the sign. The sign is an electron, but you have to put, you can't put a negative there, otherwise it doesn't make any sense. By the way, the electric field points up like that. So that's positive in this direction. So the electric field comes out positive, so you don't have to put, the little things over the electric field. That's a positive quantity. And then you need H there. Okay? And then what you can do is replace the electric field, so you can rewrite that term as Q. And then where the electric field, you can write sigma epsilon naught H. Because that's the electric field in between the plates. That's it. That was it. That's it for the first part. Now, in the exam problem, if I recall correctly, I also asked how far does it go along here. So in that case, what you have to do is you have to use the kinematic equations at that point. So that part was a little tougher. So let me just do that. And let me ask, are there any other questions after this? Otherwise, this is going to take a while. Now I have to remind you of the kinematic equations. Jacqueline, tomorrow. Okay, maybe if nobody has a problem with that. Again, if students have a problem with it, I cannot do it. Again, I cannot just arrange office hours where only a few students have access to the office hour. That's kind of unfair to the other ones. But does anybody have a problem with office hours? Say for instance at this same time tomorrow. Okay, if anybody, is everybody okay with that? Again, I cannot do it. If somebody has a conflict, then of course, I understand. I don't want to, but if nobody has a conflict, then I'm okay with it. Okay, so nobody, but maybe some other conflict? Or maybe just can't, I don't know, some other thing that there's somebody objects for some reason that I don't know. Okay, so nobody's objecting. Now, last time what happened is people didn't object, but they didn't show up. So again, I'm only doing this for you guys. If you can do it, that's great. So then let's do that. Let's continue a little bit tomorrow. Let's leave a little early today and continue tomorrow. So it give you a chance to look more. I'll upload that other missing practice thing right away. And then just you decide what you have problems with. And then we continue. Now, for this one, to answer the question how far it goes, you have to start. That was a little bit messier. You have to write kinematic equations, remember? So that went like you had the y and the x component. So for the y, you have v0, the y times t, well, that's 0 because there is no initial. And then 1/2 ay t squared plus y0 plus, and y0 is h. So the way to find, to answer how far does it go in the x direction, what you had to do was this. Oh, okay, cool, Isaias, thank you. Okay, yeah, surgery sounds, hope everything is fine. But somebody says that they have surgery, but they're cool with us having office hours. Okay, right. So for the second part, let me just finish this, which is what, I guess it was Colton that asked this. So again, let me just finish. So the first part of saying, how fast does it go? You just solve for VF. We already got that part. Okay, so that's it. You're done. That's all you had to do. That was an exam question. That's all you had to do for the first part. The second part was a little tougher. The second part is, okay, great. It hits the bottom, but how far did it go in hitting the bottom, before hitting the bottom? Now, H is the separation of the plates. I guess the separation of the plates in the problem in the exam was called D, sorry. But let's keep it H, since H goes in there, D and H are the same thing. So for this second part, what you have to do is you have to figure out at what time, first you have to figure out at what time does the electron smack the bottom plate, at what time? Well, the y coordinate of the kinematic equations is like the one I just wrote. At time t equals 0, there is no Vy. So I can make that 0. Now, what is Ay? Well, Ay is force divided by mass, right? So now here, the sign, you do have to put the Ay has to come up down. So you're going to have a minus. I'm going to put it explicitly. QE is the force. Now you have to divide it by the mass of the electron. I believe this was an electron. So this is the acceleration. Force divided by mass is the acceleration. So that I put the minus explicitly. Acceleration points down for sure. So again, I know the direction of the sign. So I'm putting it explicitly. Then I put the absolute values around the Q, so I don't worry about the sign of the Q anymore. That the sign needs to be negative. So I do this, and I don't have to worry. And now for the E, well, you can use the same, for this, you can replace by this as before. Okay. Anyway, so this needs to go in there with a negative sign. So what are you solving for here? So this is AY. So what you're solving for is the time at which the electron hits the bottom plate. So then what you have to ask yourself is, well, what is the Y value of the electron when it hits the bottom plate? Well, of course, that's Y equals 0. So that's the condition you're looking for, the T at which Y equals 0. Okay, so that's what you're solving for. That's why you need this to be negative. Otherwise, you're not solving for anything. There's two positives on one side. It's not going to give you 0. Okay, anyway, since that's a negative, you're going to be fine. So 0 equals minus 1/2 QE. Then let me replace sigma ME and then epsilon naught. And then T squared. Now this term dropped out because there is no such term. There's no Vy at time t equals 0. Okay? And then D. In this case, we called it H. That's the separation of the plates. So based on this equation, I don't have any problem solving for T. What is the time at which it hits the bottom plate? Because it's just the square root and so on, and it comes out positive. It doesn't give you any complex numbers. Of course, that would be trouble. But so it comes out fine. So that's the time. Okay, then what? What I asked is not the time. What I asked is the distance. Well, the thing is, along the x direction, we know that the speed does not change. It stays constant. V0 equals, so what we say is V0 equals V0x. And that stays there, and is not, that's a constant. It doesn't change because there is no y, there is no a, or another way of saying the same thing is this, ax equals 0. So therefore, the distance that it travels in the horizontal direction is very easy. It's just L, that's the distance when it, by the time it hits, would be equal to V0, that's all, the Vx, times the time that you find from there. And that's it. So you solve for time using this equation, and you stick it in there, and then you're done. That's the distance it travels. So that was that problem. Again, let's finish here. This is a good place to stop since we're doing office hours. We'll do office hours at exactly the same time as this class, okay? So please, I'll upload just one more practice problems package, and then you look at the prior exams, you look at those packages, and then you ask me whatever you want. But come ready with questions, otherwise the office hours doesn't really make sense. So, okay? Okay, see you tomorrow then. I'll upload that thing right away. See you tomorrow.